So now let's look at quark and lepton compositions. In this case, we will take a look at the quark compositions. The first generation U and D quarks composing the proton and neutron are constituted with generic, prime, and mutually canceling pairs of flavored Rishon elements. The Rishon elements in each 3-element column of the first row, 3-element column in the first row of composed U quarks comprise both generic and prime Rishon elements. So we can see here's generic elements and a prime. We have 2 generic elements and a prime. We have 2 generic elements and a prime in each of these U quarks. Now in each Rishon element in each 3-element column, including the 3 additional rows, compose D quarks and comprise a generic quark, generic D quark, a prime boson minus, and a neutral flavored boson plus. Now we can look at the electric charges on these 2 quarks. Here's the U quark, and as indicated, all 3 of these groups compose the D quark. And so the electric charge we see here is 1/3 plus 1/3, which is 2/3, which is the electric charge which is given in the standard model. And if we look at the electric charge here on the D quark, we'll see it's minus 1/3. But we need to look at the contribution of electric charge for these 2 bosons, and we can see that in this case we have a -1, but in this case we have a +1, so these cancel each other. So for the entire composition, the electric charge is -1/3, which is what is given by the standard model. Now, an exchange of prime elements, this prime element included in the first row, quark, and the 3rd row boson here will transform the U and D quarks one into the other. But first, let's take a look at the spin quanta on these 2 quarks. So each element contributes a spin plus or minus 1/2. So we can look at this U quark and we see we have 2 minus 1/2 and a +1, so the total spin here will be minus 1/2. For this D quark, we have 2 plus 1/2 and a minus 1/2, so the total contribution, the sum of these spin quanta, will be 1/2. Now for the 2 bosons, the pairs of elements are plus and minus 1/2, so they make no contribution to the spin. Now there is a connection, as we know, between spin and the weak charge. So let's look and see if our weak charges are consistent with the standard model. And so we had a left-handed U quark, and the standard model predicts that any left-handed quarks should have a weak charge. And so we can see that the Rishon elements are contributing a 1/3 plus a 1/3, which is 4 6s, minus 1 6, which gives 3 6s, which gives us a plus 1/2 for the weak charge on the left-handed U quark, which is what is predicted by the standard model. And here we look at this generic D quark, which is part of the composition for the actual quark composing the protons or neutron, and we see that we have 1/6 plus 1/6 minus 1/3, which is minus 2/6, so we have a 0 weak charge. And the spin on this generic D quark was 1/2, and the standard model predicts that right-handed quarks will have no weak charge. And if we look at the bosons here, we will see that in this boson minus, we have a weak charge of -1. And for the boson plus, we have a weak charge of +1. So these cancel. So the weak charge is going to only be given by the right-handed generic D quark, and that weak charge is 0. Now, so let's see. We said an exchange of the prime elements included in the U and D quark would transform the U into the D. So now we have exchanged these prime elements. And so now here we have, let's look at the electric charge, because now this is a D quark, and we see we have 1/3 minus 2/3, which gives us a minus 1/3, which is the charge which is supposed to be on the D quark. Now we have this generic D here, which has a minus 1/3, but the three of these groups compose the quark. And if we look here, we have an electric charge of 0. This is now a boson 0 after the exchange of the prime rishons. And we still have the neutral flavored boson, which we can see now has a 1/3 plus 2/3, which is a +1 electric charge. So this +1 electric charge summed with this minus 1/3 will leave us the 2/3 electric charge, which is predicted for the U quark. Now, let's take a look again at the weak charges. And so we had a left-handed spin on this quark when it was U, and now we have a right-handed spin. Well, we'll see. Because we have the contribution for the weak charge now is 1/3 plus 1/3 minus 2/3, which is 0. So to be consistent with the standard model, we will have to have a right-hand spin on this D quark. And then here on this D quark, we have minus 1/3 and a minus 1/3 and plus 1/6, which gives us minus 3/6, which is a minus 1/2 on this D quark, which is appropriate for this D quark. But remember, this D quark is part of the composition of a U quark here. And so now we see that on the boson 0, we have a weak charge of 0, but we have a weak charge of 1 on the boson plus. And if we sum that with the minus 1/2, then the total weak charge on the U is plus 1/2, which again is what is predicted by the standard model. And let's see if our spins have changed on these groups appropriately to be consistent with the weak charges they now carry. And so now we see we have a D quark is a right-handed spin, so a right-handed spin quarks have no weak charge, and so there was no weak charge on the D quark. This generic D quark is now a left-handed spin, and we saw that we had a minus 1/2 weak charge on it, which is predicted by the standard model. But this D quark is part of the composition of the U. And so we have to look and see, and we saw previously that the weak charge of 1 that was on the boson plus summed with this weak charge to make it 1/2. And so 1/2 is the appropriate weak charge for the U quark, the left-handed U quark. So we see in this way, we have the composition of the quarks that compose the protons and neutrons in the Standard Model. And we can see that the electric charges, the spin, and the weak charges are the appropriate charges predicted by the Standard Model. Now, we will look next at lepton compositions, and then we'll come back to look at these other quark compositions and the transformations that take place when we have an exchange of the prime Rishon elements.